Hello, welcome to week 7 of CIS 165, Introduction to Programming Using C++. Today I'm going to go over relational operators and logical operators, and I'm also going to cover a little bit about conditions using branching statements with if and if else, so that you learn a little bit about conditionals, programming statements. What is a relational operator? Well, a relational operator are operators that will return a true or false value depending on the condition that you apply using these relational operators. There are 6 relational operators and there are 3 logical operators. I'm going to go over each and every one of these. This one is less than. This one is less than or equal to. This one is greater than. This one is greater than or equal to. This one is equal to. And this one is not equal to. For the logical operators, this is not. This is the operator for and this is the operator for or. So how do these work? Well, when you're dealing with relational operators and logical operators, you have to understand that the result of an expression will always give you a true or false value. Again, the result of a relational expression or a logical expression will always give you a true or false value. Here, I'm listing the operators themselves and the order of precedence with their associativity. You remember what precedence and associativity is, right? Precedence meaning which one is going to get evaluated first, and associativity meaning that if they are of the same precedence, which way are they going to get evaluated? From left to right or from starting from right to left? Okay. The first operator that has precedence of 1 is a not. So if you ever see an expression that has the not operator combined with an addition, you know that the not operator will always get evaluated first. So let's go over an example. If I say not do not 1, and I'll explain to you why I'm using not 1. Or 6 plus 5. Put this. The way that C++ represents true or false values is by using the value 1 as true and 0 as false. In this particular expression, when I'm saying not 1, you can think of it as saying not true. When you say something's not true, then that means the result of this is false. Okay? Now, when we're talking about order and precedence, I don't want to go into the or statement just yet. That means that this expression will get evaluated first, and then the addition expression will get evaluated because of their precedence. So you see that not is going to come before the addition and subtraction. Basically what happens is the not comes first, then you have your arithmetic operators, and then you have the relational operators. Okay? And as you see here, we're repeating what I just said in the previous slide, what the meaning is. So less than or equal to, greater than or equal to, is equal to, is not equal to. Okay? And then the logical operator is not, and then the value, and the result is going to be the opposite. So not value is false if value is true. Basically, I don't want to confuse you with this jargon, but you're basically saying if something's not false, then it's true. And if something is not true, then it's false. So you're saying the opposite. Okay? So any expression within this, so value itself can be an expression. If it results in a true when you say not true, then you're always going to get the opposite, which is false. And then always, if you say not false, then you're always going to get the opposite, which is true. Then you have the logical operator and. And the only way that this expression involved with an and operator is going to be true is if both left and right operands are going to be true. Otherwise, you're going to get a false. So if you have true and true, then that'll be true. But if you have true and false, you're going to have a false, or false and true, you're going to have a false. And then obviously false and false will give you a false. Again, the and operator will only return true if both operands are going to be true. Okay? Both operands need to be true for this to be evaluated as a true. And then the or operator, which has two operands also, it's only going to return false when both operands are false. So if they're both true, or either one of them is true, then they're both true. So you can look at it two ways. You can either say it's only going to return false when both operands are false, meaning this is false and this is false. Or we can also look at it the other way, where it's always going to return true if one of them is true. One of these operands is true. Okay? So let's talk about using them in an expression. So say you have two variables, temperature and humidity. Okay? So we'll declare them here, and we can go over these exercises so you understand. So let's say temperature is equal to 60 and humidity is equal to 80. Okay? With these operators, you always have to ask the question. So if I write this expression, temperature, humidity. Let's talk about this expression. We're using the greater than operator, which is a relational operator, right? Whenever you have an expression, you have to ask the question for you to evaluate. Is x greater than y? And always ask those questions, because these are always going to result in a true or false. So for this particular expression, the way you would read it is temperature greater than humidity? And if we substitute the values and say, is 60 greater than 80? And I'll write it here. Is 60 greater than 80? You just ask the question to yourself and you answer it as if you were asking yourself just in a normal language sentence. Is 60 greater than 80? And I just want to explain to you what I'm doing with 60 is just an arbitrary number that I came up with, and humidity equals 80 is just another arbitrary number I came up with. What I'm doing here is I'm substituting the values and saying, well, temperature is 60, so is 60 greater than humidity, which is 80? Will that give you a true, or will that give you a false? So you think about it and you say, well, is 60 greater than 80? No, it's not. So if it's no, then you say false. So what this is going to print out is going to be a 0. So if I run this, There it is. It's a 0. Okay? Let's take a look at a little bit more. So here's a more difficult one. Okay? It has a mixture of arithmetic operators and relational. And you could do that. That's perfectly okay. So, for instance, I'm going to declare val1, val2, and val3. So let's look at this. And some are harder to translate because of just how they're written. So we'll take this. Just say C out. If I put these in parentheses, I won't get a syntax error, because if I don't, I will get a 6. So you have to look at this expression and decide what you're going to evaluate first. You have to go back to the precedence chart. Remember the precedence chart? If we go back up, who wins? Well, the not is here, but there is no not operator here, so we're good with that. But there are multiplication and addition ones. So we have to evaluate them first. We have to multiply 5 times 5, because val1 is 5. 5 times 5 is 25, minus 4. But remember, who goes first? Multiplication. So you would do these first, then these, and then actually do these first, then these, and then the result of both of these, you subtract them, which will give you now part of a number to compare against 0.0. So if we do this in a calculator so that we see what the order of operations are, we first start with val1 times val1, right? So it's 5 times 5 is going to give you 25. And then you're going to do 4 times 50 times 0. And that's going to give you 0. So 25 minus 0 is 25. And then we ask the question, is 25 greater than 0.0? Think about it. Is 25 greater than 0.0? Yes, it is. Meaning that we're going to get a 1 or true. So if I run this, there it is. There's a 1. It's going to return true. So let's go back and continue. Now the equals to is different from the assignment operator that we've been talking about in the previous programming assignments, and you've been using that all over your programming assignments. There's an assignment operator with one equal sign, which means that you're assigning one value to another, right? So you remember that if I do, let me comment this particular expression is assigning the value of 5 to the integer value of to the integer variable of val1. So val1 then has a value of 5. That's an assignment operator. But if I say val1 is it equal to 35, now I'm using a relational operator here, and I'm asking the question, is 5 equal to 35? And the answer is no, it's not equal to 35, right? We ask the question. Always think about this when you're doing relational operators and conditional operators. ask the question. And logical operators. So, if I run this, it's not. It's false. 0. Okay? And then you have the not equals to, which will say, is variable or literal not equal to something. So, I'll give you an example. If we say char letter is equal to E, right? Letter is not equal to Q. We ask the question, and you got to be very careful because you got to practice this. You can't just get it and think that once you listen to this lecture you're going to understand it fully. You have to practice this, and I have a couple of assignments up on Moodle that you can practice on. But for this particular one is a little tricky. You ask the question, is letter not equal to Q? Well, what's the value of letter? It's E, right? Is E not equal to Q? Yes, it's not equal to Q. So that means that I'm going to get a true. Okay, that means I'm going to get a true. There you go. 1. Because it's not equal to Q. E will never be Q. But if I say Q here, right, and I ask the question, is letter not equal to Q? So you're asking, is Q not equal to Q? Is Q not equal to Q? That's false because it is equal to Q, right? Q is Q. So if I replace this letter with the Q, which is the value, then they do equal. So then that's false. There you go. It's 0. This particular one is a little bit tricky. You just have to sound it out in your brain and you have to write it out. And you have to answer the question. Is this not equal to that? No, it's not. Then it's true. If it is equal to that, then it's false. Okay? So, a little bit of an exercise. If you write your program and you declare an int val1 as 4, int val2 as 6, see if you can evaluate your expressions by writing these out. So I'll do the first one, okay? Just so you see how I'm writing them out. So val1 is 4 and val2 is 6, right? So if I was writing out val1 is less than val2, I'll say parentheses val1, val2. According to this chart, I should get true because you ask the question. So you ask the question, is 4 less than 6? Is 4 less than 6? No, it's not, right? It's not less than 6. If I run this, I'm sorry, it's not less than 6, so that's true, right? Is 4 less than 6? It's true. It is true, right? Because you're asking the question, is 4 less than 6? Yes, it is. Yes, it is. So that's why you get a true result, which is a 1. Okay? Is 4 less than 6? Let's do one more, and then you can do the rest on your... So we'll do val1 plus 2 less than val2. So if we do the following, you ask the question. First, you need to see the order of precedence, right? Addition goes first, left to right. Val1 is 4. 4 plus 2 will give you 6. And you say, is 6 less than 6? Is 6 less than 6? Now the thing is, when you have two similar operands that are exactly the same, not similar, but when they're exactly the same, and you're doing less than or greater than operators, your answer is going to be false because you're not using the equals to. So you're saying, is 6 less than 6? No, it's not. It's not. So when I run this, it's going to give you false. Okay? False. Again, I repeat. When you have the less than or greater than, and you're comparing numbers that are exactly the same, you're always going to have a false value because 6 less than 6 or 5 less than 5 is always going to give you that 5. It's not going to give you the 5. It's going to give you a false. Okay? So as I was saying, if you have two numbers exactly the same and you're using a less than relational operator or a greater than relational operator, for example, if I do 5 is greater than 5, that's going to return false. Either way. So if I do 5 less than 5, that's also going to return false. If I do a 5 greater than or equal to, or less than or equal to, now it's going to say, is 5 less greater than or equal to? Yes, it's equal to. So that's true. And same thing here, is 5 less than or equal to 5? And that's also true. I think in mathematics, that also comes into consideration. If you know your algebra, then you're fine. Try these examples using what I just did and see how they evaluate. And I'll give you a couple of minutes to do that. And I'll pause it for a second, and then we can go continue with this. So the conditional and relational operators that we've gone over, you have two types of flow of control in C++. You have the sequential flow of control, which is what we've been doing so far. Typing in commands, reading in input from the user. But then now we have a new weapon to use in our programs, which is called selection or decision. Because now, based upon the values that are represented as output from these expressions, we can change the direction of execution. We'll get to that a little bit later, but just keep in mind that you think about yourself in a road, okay? You're going down the highway, and all the time you always ask the question, what exit should I take? Should I take exit B or exit A? Same type of concept with these conditions. If this is true, then do this. If it's false, then do that. We're going to learn about conditional statements which use the relational operators and the logical operators to make a decision. And you do this every day. When you're driving down the highway, when you're going to school, you may want to take a different route. If there's traffic on this, then take this other road. Let's take a look at some of the examples for the operators. This is real world problems. So I'm asking you to write an expression for each. Tax rate is over 25% and income is less than 20,000. Basically, if I was going to write that in an expression, you'd have a variable called tax rate. So I would say double tax rate is equal to some arbitrary number. We'll say D. Sorry, I haven't been keeping up with the naming conventions, but now is a good time to do it. So what I'm asking you to do is write a relational expression, a relational logical expression with this. So tax rate is over 25%. So over means greater than, right? So you have to look at the key words in these examples. So over, greater than 25%. So how do you represent percentage in C++ is you have to represent it in a decimal number, so 0.25. And you remember the AND operator, the logical operator, income is less than 20,000. So and then we'll have another variable here, double the income, and I'm just putting in arbitrary values, and income is less than, so less than 20,000. So that would be our expression, which consists of relational and logical. Important thing to realize about these expressions is you want to always evaluate, you always want to see what you want to evaluate first by putting the parentheses. So I wouldn't rely on the C++ precedence or associativity, because you can get yourself in trouble. Just like with the operators. What I would suggest is anything you want to evaluate it first, then I would do something like that. So that means that guaranteed this one will get evaluated first, and then this one will get evaluated first because of the parentheses. Let's try the second one. Temperature is less than or equal to 75. So you'd have something like I temperature is less than or equal to 75, or humidity is less than 70%. What's the sign for or? The logical operator. Or humidity is less than 70%. 70% is represented by 0.70. So that would be the expression. So what I'm asking you to do is write expressions for each, and we've just gone over 2 examples, okay? And after this slide is the answer. So tax rate is greater than 0.25, and income is less than 20,000, right? And then temperature is less than or equal to 75, or humidity is less than 0.70. And then those are your answers for the other 2. So let's take a look at the precedence chart. So say you have this expression here, and I'm asking you for the order of execution. The order of execution in this expression here says that division has the highest priority. Division would say 1 divided by whatever the value of number is. Now I asked the question, what happens if number has value of 0? If the number has a value of 0, C++ does not allow you to divide by 0. It'll give you a runtime error, division by 0. So this would not continue to run. Going back to our ordering, so you have this would execute first. Then you would have this would execute because the less than has the next priority. Then the not equals to, so this would execute afterwards. And then finally you would do the AND operator. Couple of things to warn you about Boolean expressions, because these relational and logical operations are Boolean expressions. They return a true or false. Boolean expressions is going to have an outcome of true or false. It's going to have any valid combination of operators and operands. As we've seen before, you can have an addition with a division with a less than or equal to and an AND. Every expression is going to have a value depending on what type of operator it is. So for arithmetic operators, you're not going to necessarily have a true or false value. You're going to have a result. as we went over with the val plus 1, val plus 2. But then any relational expressions or logical expressions will have a value of true or false. Make sure to construct your expressions carefully. Use parentheses as needed. That's why I was warning you about. Just use your parentheses. Don't depend on the compiler to do the precedence and associativity for you. Okay? Don't depend on the compiler to do the precedence or the associativity. Okay. So, let's go into now something called if statements, which is what I was talking about, changing direction of execution. Changing direction of execution. And here is a question regarding a problem. What went wrong? This is supposed to display healthy air, right? And this expression, naturally, we don't write C++ expressions this way because we just don't. When you're trying to compare two values, you usually have to always repeat the condition. In this particular case, this is written incorrectly. What this is saying is if AQ index is greater than 50, right? Or 50 is less than AQ index, and AQ index has to be less than 80. Okay? But if we execute this according to our precedence chart, what you're really saying is evaluate this first, then the result of that would evaluate with this. And remember, this is going to give you a what? What type of result? What did I tell you that all relational and logical operations give you? A true or false. So this particular expression says compare 50 less than AQ index, which is 35. It's not. So it's false. Then it's going to do false, which is 0, is less than 80. And that's true, right? Is 0 less than 80? Which is what I'm talking about here. This is true. Okay? This is true. So that's not the type of answer we want here. We still want a true or false answer, but what you're really looking for is only do it if AQ index is it's greater than 50, or AQ index is less than 80. And less than 80. So the correct version would be is only writes healthy air if the AQ index is greater than 50. So it's between 50 and 80, right? Between 50 and 80. So when I say between, you're saying from one border to another border, from one min number to another max number. And when we're doing that, the best way to do that is to use an AND statement. How does this work now? The if-else statement, which is the conditional statement, always must have an expression that evaluates a true or false. So anything between the if is either going to give you a true or it's going to evaluate to false. But now I'm going to teach you what happens when you're trying to execute two paths. The first thing to note is anything between here in statement A could be many statements. Okay? It could be many statements. At most, you're going to have either an execution here or here. You're never going to have an execution for both because, again, there's only a true or false. If this is true, it's going to do anything under the if. If it's not true, meaning if it's false, then it'll do anything after the else. That's the way if-else works. So if we look at a real-life example, okay, if there's traffic today, then take Route 4. Otherwise, take Route 17. Okay? So you ask the question, is there traffic today? Yes, there's traffic today. So we're going to take root 4. If it was a Friday night and you're asking the question, is there traffic today? No, there's no traffic today. So then it's going to jump out in here and say, I'm going to take root 17. So you're going to, it's something called a two-way selection, right? So if we break it down into a flow chart, you're going to have execution of one of two actions, either the true one or the false one. The true one will go where the if clause is, and then the false one will go into the else clause. So if we look at the expression, the coding example here, okay, a little bit hard to evaluate, but we just do it step by step. Don't let this overwhelm you. I know there's a lot of things going on here. You have the relational logical operators going on here, and then now you have a conditional statement here, right, with the if else. But we take a look and we say, we evaluate, right? If car doors is equal to 4 and driver age is greater than 24, meaning that this whole expression is, if it evaluates to true, then you're going to execute this block of code. That's what this means. If this whole expression evaluates to false, then it'll go and jump into the else. Couple of other things to be careful here. With the if statement, you surround code within the if using braces. Okay? Using braces. So if you have one or more expression or statements, program statements to execute, you should use braces. Same thing with the else. You open the code block, write your expressions or expression, and then close the code block with the curly brace. This is outside the if else, so this will just execute no matter what. We ask the question here, if is car doors equal to 4? So whatever answer that is, you say, okay, it's true. Is driver age greater than 24? Say for instance it was true. So then you have true and true, okay? And you have to go back to your rules of the AND logical operator. In what particular instance is an AND going to evaluate to true? When they're both true. True and true will give you true, okay? That's the only time that the AND operator will give you a true result, when both operands. So we call this an operand, and we call this an operand. Now, an operand could be either one variable or it can be an actual expression. So that's a little tough concept to grasp here. But again, if you go over the operators and you start knowing them by heart of how they react, then this will be easy to you. Okay. So if you omit the braces and you have two or more statements, then you're going to have a syntax error. So this is illegal. You cannot do this. So what is a syntax error? The syntax error is, even though you have this in the body, but this is going to end the if statement. This particular statement is considered a standalone, but it still doesn't know if it's part of the if or if it's just outside, but then you have an else here, so it doesn't know. You need a brace around these compound statements. So these are called compound statements, okay, because there's two or more statements within the body of an if and two or more statements between the body of an else, okay? You can omit the braces if you only have one simple statement. So in this particular example, you have if this, then you have one statement here. Else, you only have one statement here. Again, this is not a syntax error because you only have one statement after the if and then after the else. Now, could you put a brace even though you have a simple statement? That's legal. You could do that. So it doesn't really matter how you do it. If you have one statement, you can either omit the braces or you can put them in. I usually don't put them in. It's up to you of how you want to code your C++ program. But if you have two or more statements, compound statements, then you must put the braces as you see here. If this, then do that. You have two statements here, so open and close the braces. Okay, so next time you're writing your if and else, make sure you have your braces lined up, because they may cause you a syntax error. Okay, so take a look at this problem. Assign the value 0.25 to discount rate and assign the value 10 to shipping cost when purchase is over $100. Otherwise, assign value 0.15 to discount rate and assign value 5.0 to shipping cost. And then either way, calculate the bill. This is a problem. I'm giving you a problem to do. Okay? So, basically, when the purchase is over $100, then you're going to assign 0.25 to discount and $10 to the shipping cost. And this is what we're doing here. If purchase is greater than 100, then assign 0.25 to discount rate and shipping cost 10. Otherwise, assign 0.15 to discount rate and value 5 to shipping cost. But either way, calculate the bill. So the bill here is, total bill is purchase minus purchase times discount rate plus shipping cost. Okay, this is just an arbitrary formula that is part of the problem. Usually these formulas will be given before the problem is inside the problem. Okay, now on Moodle I've put some assignments on there so you can practice for your relational operators. So make sure that you do go over that and write them out. If you have any questions regarding that, please let me know. This is very important that you understand the relational and logical operators. Make sure you do those assignments because you need to know these by heart. You need to know that two ands, if you have one and, it's only going to be true if they're both true. I know that by heart because I've been doing it for years. You're not going to get to the point, but you need to get to the point where this is all not memorization, it just comes second nature to you. Okay? So you can look at this sheet of paper that I have. I've attached it on Moodle, and you can see the condition with the solution. Okay, so you have a condition and then the solution here in C++. Okay, condition, solution, condition, solution. Make sure you study that. Take a look at that. Read it through yourself. Same thing for the logical operators. A couple of things that statements that we just went over in the lecture. Okay. And then the last thing I want to go over is something called a ternary operator. Okay. A ternary operator. So a ternary operator is going to ask the question if else. Okay, if else. So what happens is you have expression 1, question mark, expression 2, and then expression 3 was separated by a semicolon. Very simple. Don't get scared by this. So what happens is expression 1 is going to be a Boolean expression. A Boolean expression. If expression 1 is true, then expression 2 is executed. Otherwise, expression 3 is executed. So it's basically the same thing as an if-else, just in shorthand. It's called a ternary operator with a question mark. You have a question mark and a colon. So you're just asking the question. If true, then do this. Otherwise, do that. So this is the same thing as saying, so if I take this, okay, I take that, and you can always use this yourself. This is the same thing as saying, if expression 1, then expression 2, else expression 3. It's the same thing as saying that. Okay? And expression 1 is what? it's a Boolean statement which is going to return a 0 or a 1. It's going to return a 0 or a 1. Okay? So that's what a ternary operator is, and it's a conditional operator. And this goes into more of the ternary operator, and I give you a couple of examples. So if value 1 is greater than value 2, question mark, subtract. Otherwise, add. Right? So assume that value 1 is 12 and value 2 is 7. We try to evaluate this. Okay? We try to evaluate this. And I give you how you break it down with the if-else. So the ternary operator is basically an if-else. Okay? And again, this expression could be a combination of multiple relational and logical expressions or operators with operators and operands. Okay? And that's about it. If you have any questions, please let me know. I'm always here to answer your questions. The important thing is, please do the exercises on Moodle, which will be available this week. Please do them, practice them, go over them over and over and over again. And you shouldn't have a problem once you go over these. Again, if you have any questions, please let me know. Okay? Thank you very much. I will see you next week. We will talk about, on week 8, we'll continue with the if statement, switch case, selections, continue with the if-else, and then you're going to have a quiz and a program assignment so that you can work on, okay, using the knowledge that you have learned. Please go over these exercises. If you need to go into the book and do some of the sample exercises, please do so. There are a lot of exercises in the book that you can practice on in that chapter. Okay? Have a good week and happy coding.